Okay, ladies and gentlemen, good afternoon or good morning or good evening, depending on where you are on this planet. My name is Alexei Laureshin. I'm going to be the moderator of today's session. I am a researcher, a teacher at Lund University in Sweden, but today actually I will wear a different hat. I am representing the Traffic Safety Research Journal, where I am the editor-in-chief. And just to give you a very short personal introduction, why we invested time and efforts into setting up a new journal and why we eventually decided to run these webinars. I remember times when I was a PhD student and we had a meeting room and there were shelves with old journals, accident analysis and prevention from 1980s, 1990s, and eventually during coffee breaks, you would go there and pick up randomly anything, any random issue from the shelf, and you open it and like, that was interesting, actually. Have they thought about that particular problem already there? So basically, every second article I could read and I would find it meaningful, interesting, relevant. And something changed later. My impression is that in the chase for indexes, arch indexes, citations, all that type of things, which is of course important, but somewhere we made the wrong turn. Today, I am signed up to follow most important journals in traffic safety. I receive 30, 40 notifications about new publications. I don't have the same feeling that, wow, this is interesting, this is relevant. For half of those papers, I hardly understand the titles, what it is all about. If I open the paper, I don't understand how to use this paper to save lives in traffic. So that was kind of the main motivation for starting up traffic safety research as a new journal. We want to get back on the track of making research relevant, connected to practice, and connected to solving real problems. And then it turned out it's not that easy to explain for ourselves or explain for others, explain to our authors what type of papers do we really expect. So that's how this idea of having webinars and discussing what does it make to write an excellent traffic safety research paper, what is important, what to think about. Yeah, so that's how the idea come to invite the most respected, the most known researchers with years of experience and to share a little bit of their wisdom. Today's speaker, it's a profile within traffic safety community that doesn't really need much introduction. Rune Elvik, he has spent 40 plus years at Institute of Transport Economics in Oslo, in Norway. He published more than 150 journal papers on traffic safety. He contributed to the Highway Safety Manual. He was the first editor of the Handbook of Road Safety Measures, and the list goes on and on. So for me, it was a very natural choice to invite Rune to talk about, well, how do you do that excellent research? What are the secrets and what we, the researchers who might not be as senior and as seasoned and experienced, what can we learn from that? So before I gave the floor to Rune, just a couple of words about practical organization of the webinar. Rune will make his presentation. It will take about 35 to 40 minutes, and the time remaining is reserved for questions. So as you see, we are sitting just in one huge Zoom meeting. So technically, everyone can start talking at any time. And I would ask you not to do that. So please keep your microphone muted. But when it's time for questions, I would ask you just to write your name in the chat, and I will call out people following that order. And the idea is that we close down, we stop at in 1 hour exactly. So 4 o'clock, that's the end of the webinar. But there would be more occasions. There would be more occasions. We have already planned the next webinar in that series. It will be announced just in a few days. And also, this webinar is recorded. So we will put a recording on the YouTube channel of the Traffic Safety Research Journal, and also we will share the link through our usual communication channel. So watch out for LinkedIn posts, for our newsletters. It will come to you. Give me a day or two to prepare everything technically, but it will come. Okay, great. Now, Rune, I think you can take over. The floor is yours.
Thank you. Well, I have actually been at the Institute of Transport Economics for 45 years. And my current count of journal papers is 191, just to update you. I hope you can see my screen. Can you?
Yes, it looks correct.
Yes.
Fine, thank you.
Yes,
Well,
I can see it.
Thank you. The title of this presentation actually contains, as I interpreted, 3 different questions. There are, as I interpret the heading, 3 questions included in it. First, what do we mean by excellent research? The second, how should it be conducted? And the third, how should it be published? And I will focus mostly on the first question, I think. I have spoken about that a number of times before, so I feel that I am perhaps starting to repeat myself, but I hope not everything is a repetition, that there is some new elements here as well. So we can go to next. Yeah. First then, what do we mean by excellent research or a good study? By that, I think we mean a piece of research which is excellent if it does not have any weaknesses of data or method that have influenced its results. If a study does not have any such weaknesses, then the results of that study are said to be valid or free of any bias. And it is widely agreed in methodological research that randomized controlled trials, experiments in which there is random assignment to a treated group and a control group, is the best design. It is widely regarded as the only study design that ensures valid results. And it is mandatory, in fact, in some fields, in medicine, for example, if you want to test new drugs or new treatments, whenever it is possible to do so by means of a randomized controlled trial, it should always be done that way. However, in our field, the road safety studies, randomized controlled trials are quite rare. I tried to make a survey of them a few years ago, and I concluded that less than 2% of the studies that we refer to in the handbook of road safety measures are really randomized controlled trials. And another problem is also that even experiments or randomized controlled trials can go wrong in various ways. They can get biased results, and I will show one example of that later on. Now, next, to help us assess the quality of our research, I have found it useful to apply the validity framework that was developed over a number of years, first by Campbell and Stanley in 1963, and then updated by Cook and Campbell in 1979, and finally by Shadish, Cook and Campbell in 2002. And in this framework, a distinction is made between 4 types of validity. And for each of these 4 types, several criteria are proposed. That there are long checklists of items to assess each type of validity. Now, in applying this framework to road safety studies, I have slightly reformulated or redefined a couple of these criteria. First, statistical conclusion validity. By that, I would think of, or I would mean, the degree to which the results of a study are representative of a known population. And that means that it refers to whether we can generalize the results to that known population or whether we cannot do so. The second main type of validity is internal validity, and that concerns the degree to which the results of a study can be interpreted as showing causal relationships. And this is quite important when we are evaluating road safety measures. When we speak about the effects of the road safety measures, we are actually claiming that we have found a causal relationship. Otherwise, using the word effect is not correct. When we are talking about effects, we are claiming that those were produced by the road safety measure we have evaluated and not by something else, not by some different agent. Theoretical validity, that is what Shadish, Cook, and Campbell call construct validity. And in their interpretation of that, it means how we define operationally theoretical concepts. But in the field of road safety studies, I propose to define it a bit differently. By theoretical validity, I am thinking about the degree to which the results of a study or a set of studies support a theory specifying systematic variation in effects. Because it is increasingly understood that the effects of road safety measures are not always best described in terms of a single point estimate, a single figure stating the percentage change in the number of crashes or a percentage change in number of injured people or so on. Usually, or more commonly, the effect varies depending on various characteristics of the measure and various characteristics of the system in which the measure has been implemented. And the more capable we are of describing such systematic variation, the higher is the theoretical validity of the results we obtain. Then the fourth and final type of validity is called external validity. And it refers to the degree to which the results of a study or a set of studies can be generalized to other contexts than those in which the studies were made. And this is not a statistical generalization. It is a generalization based on other types of considerations. For example, are the countries similar to my own country? If we don't have any Norwegian or Swedish or Dutch studies about something, can we rely on British, German, and French studies? Or are those countries too different from our own country to transfer the results, for example? Another consideration is how old studies can get before we think they are outdated and too old to continue to be referred to. Let's move on then to the next one. Thank you. Yeah, I would say that all these types of validity comes in degrees. Now, of course, in saying so, I'm not saying that it is possible to measure it very precisely. I mean, you can certainly propose some kind of numerical scale or something, but it will inevitably have a large element of arbitrariness, and other researchers might develop different numerical scales. But all of them should be regarded as variables. And another thing that we should note right at the outset is that few, if any, studies will have the maximum conceivable validity. It will rarely be the case that the study scores maximum with respect to all types of validity. But on the other hand, there are unfortunately some studies that have so serious weaknesses that we cannot really take their results seriously. And another thing that I will come back to in this presentation is that the types of validity are, I think, to some extent compensatory. That means that if a study is weak in terms of one type of validity, it can be strong in terms of a different type of validity. Although we, of course, would ideally like studies to be strong in terms of all types of validity, this, unfortunately, is rarely the case. Okay, let's go on to some examples then next here. Yeah. I will first deal or say something a bit about statistical conclusion validity. As I see it, it is generally low in road safety evaluation studies. And the main reason I have for saying this is that there is a widespread use of convenience samples or data that happen to be available. This is very common when we are evaluating road safety measures. Roundabouts, for example. We collect data on a number of junctions that have been converted to roundabouts, but we don't know what the population of junctions is. We just have collected data that are easily available and evaluated before and after, or with some other study design. Actually, if you are a bit strict, which most researchers are not these days, but if you are a bit strict, what we commonly do, estimating significant levels or confidence intervals for studies that are not based on random sampling, is an abuse of statistical techniques, because those statistical techniques that we employ, that we make use of to estimate significant levels or confidence intervals, are based on sampling theory. They're based on a body of statistical theory, which tells us how various samples vary from one sample to another. The random variation you get if you draw a sample at random from a known population. But still, if you open a journal or read a report or anything, you will, of course, almost always find estimates of significance or confidence intervals. So this abuse is so common that there is probably no hope of ending it, I think. And my cure to this state of affairs is replication, and again replication. Because if you replicate studies, there is a fair chance that the samples, to use that phrase, will be different. That not all studies of roundabouts, for example, will be identical. Some of them will contain a lot of roundabouts in urban areas. Other studies will contain roundabouts in rural areas. Some of them will contain a lot of roundabouts that have 3 legs. Other studies will contain roundabouts that have 4 legs. Some of them will deal with large roundabouts where the central island is large. Some of them will deal about roundabouts with small central islands, and so on. And if we get lots of studies that vary with respect to these and perhaps other characteristics, and if we can then study how the results of those studies are related to those characteristics, then we have some basis for generalizing and for finding what I referred to initially here as systematic variation in effects, depending on the characteristics of the measure and so on. Another reason is that the traffic system keeps changing all the time, and these changes are of course not related just to the infrastructure, but to the vehicles that are used and to the population of road users as well. And we don't have the same population of drivers today as we had in 1985, for example. Many of those drivers are no longer alive and no longer in the population, and new ones have entered. So the only way we can know how long knowledge lasts, how long we can apply studies of, for example, roundabouts that were made in 1985 is to continue to do such studies, to update it continuously. Okay, next. Yeah, one thing I would like to insert at this point is that the usual presentation of the results of statistical analysis, either in terms of significant levels or in terms of confidence intervals. I prefer confidence interval. That is not always, I think, very informative. In a paper that was published in Traffic Safety Journal, it dealt with the long-term trends in road safety in Sweden and effects of road safety policy in Sweden. I produced this figure because the policy variables that were included did not have were not statistically significant. But still, if you estimate the full probability distribution, like I did here, where 1.0, that's no effect. 10, that means you have a 10-fold increase in the number of fatalities, and 0.1 means you have a 90% reduction in the number of fatalities. Then you can see that a large part of the probability mass, 82.5% of the whole probability distribution, is located to the left of no effect. So that means that even if this finding was not statistically significant, it is still much more probable that it was associated with a reduction of the number of fatalities than the opposite. It is more than 80% probable that the policy variables contributed to a reduction of the number of fatalities. And I would like to see more examples of presentations like this. Okay, next. Yeah. Internal validity is probably, I would say it is the biggest issue in road safety evaluation studies. And as I said, in defining the different types of validity, it refers to support for causal inferences. And I would define that as an absence of confounding, or as good control for confounding as the study design allows for. Randomized controlled trials eliminate confounding if randomization is successful and if there is no behavioral adaptation to the experiment. Behavioral adaptation will occur if there are human subjects, or may occur if there are human subjects in it. and it is usually referred to as a Hawthorne effect. It is got that name from the first experimental study in which such an effect was found. And it was, of course, not an intended effect of the experiment. It was an unintended effect, which was not supposed to occur. No observational or non-experimental study will ever control completely for all potential confounding factors. The best we can ask or hope for from an observational study is that it controls for the most important known confounding factors. And in many cases, that will be quite enough for us to apply the study and to use it for deciding on the use of road safety measures. Let's look at some examples here. In the next one. Thank you. Yeah. I will make a bit of an advertisement for what I think is the most successful road safety experiment ever made. And that was the experiment, the randomized control trial with periodic motor vehicle inspection, which was carried out in Norway between 1986 and 1989, was published in one report in Norwegian, one report in English, and one paper by a colleague of mine in Accident Analysis and Prevention in 1992. Let's look at the first part of this table. Well, there are three experimental conditions. One group was inspected annually, which means that they should be inspected 3 times during the 3 years when this trial lasted. One group was inspected once during the 3 years, and one group was not inspected at all. So if we look at the first part of this table, which I call check of pre-trial equivalence, that is a test of whether randomization was successful. And the idea is very simple. If randomization was successful, there should not be any large differences between the 3 groups. And as you can see, there were no large differences. Percent with collision insurance, for example, 75.2, 75.0, 75.1. Or moving further down, mean year of birth of car owner, 1947.2, 1947.1, 1947.0. These are not really meaningful differences. I am not sure if they are all statistically insignificant. It might well be the case that perhaps one of them actually was statistically significant because the sample was very large. It consisted of more than 200,000 cars. So each of these groups contains about 70,000 cars, which is a quite large sample, of course. Then the next part of this table deals with implementation of the treatment. And ideally speaking, of course, in the first 2 groups, it should say 100%. But it says 67.8 and 68.6. And ideally speaking, the third group should be 0%, but it was 14.2. This very often happens in actual experiments. But still, the main message, though, is that there are large differences between the 3 groups with respect to the percentage that were treated or were inspected then. One problem you have in many experiments is that people or subjects, or in this case cars, drop out of it. It is called attrition, that they drop out, and if the percentage dropping out of the experiment varies between the groups, you have a problem. As you can see here, those differences are very small, 6.1%, 6.1 and 6.6. And then finally, there is the possibility that the owners of these cars might have adapted to the experiments. They could do so in two ways. They could sell the car. Very few people did that, 4.8%, 5%, and 5%. And when they knew the cars was going to be inspected, they could try to repair it before it was presented for inspection. And the numbers at the bottom show the number of defects that car owners repaired before showing up for inspection. And again, that number is quite similar in all the three groups. So there was no behavioral adaptation that created any differences between these three groups. If we look at the next one, we can see a rather different story. This was also a randomized control trial dealing with winter speed limits in Finland. And all the roads had a speed limit of 100 kilometers per hour before, and the treated group had this speed limit reduced to 80 kilometers during the winter season. And the control group retained the speed limit of 100 kilometers during the winter season. Now, as you can see here in the test group, the group that had the speed limit reduced, the accident rate, the number of injury accidents per million vehicle kilometers was 50% higher than in the control group. And this means that there is probably a regression to the mean in the treated group, which the design did not control for. And that means that even if this was a randomized control trial, it did not actually ensure control for regression to the mean, since that is likely to have been different between these two groups. Now, how different it was, we of course don't know and can't find out either. But there might be a difference there. Okay, next. Yeah. You might wonder, of course, if control for confounding makes a difference, and it in some cases actually makes a very large differences. Many years ago, I had fun comparing studies of what was referred to then as black spot treatment. Today, the word hazardous road location is more frequently used than black spot, and it refers to road locations that have an abnormally high number of accidents, of course. And there has been many studies of that, and claims have been made that this is a very effective approach to road accident prevention. And if you look at the studies to the left, which did not control for any confounding factors, you certainly get some support for that claim, because they found a reduction of 55% in the number of injury accidents. But as we move to the next part, you have studies that controlled for one confounding factor, and that confounding factor was either traffic volume, long-term trend, or regression to the mean. Then you see smaller effects. Then you move to the next part of it, containing studies that control for two confounding factors, which were either trend and traffic volume, trend and regression to the mean, or trend and accident migration. Then you get still smaller effects. And then you have studies that control for three of these confounding factors: trend, regression to the mean, or accident migration. And the estimate of effect is 0. And I did not find any study that controlled for all the four factors, that is trend, regression to the mean, accident migration, or change in traffic volume. So when you see this, at least I get a bit in doubt about whether black spot treatment really is as effective as some studies have claimed that it is. Okay, let's move on to the next one. Yeah, well, nowadays the empirical Bayes method is regarded as a very good method for conducting before and after studies because it controls for regress to the mean and it controls for long-term trends. And if you have data on traffic volume or changes in that, it can control for that as well. But this method is quite demanding in the most advanced version of it. There are several versions of it, but if you want to use the most sophisticated, it requires the development of a multivariate accident prediction model. And this, of course, may not always be possible. And so some years ago, I asked the question if simpler methods can be applied. And if those simpler methods still produce unbiased estimates of effect. So let's have a brief look at what I found out. What I found out was published in Accident Analysis and Prevention in 2012, Analytic Choices in Road Safety Evaluation, Exploring Second Best Approaches. And the second best approaches were they did not apply the empirical Bayes method, but some simpler method. And I write here at the bottom of the abstract 2 second best techniques, that is techniques other than the empirical Bayes approach for controlling for confounding factors were tested. The techniques were found not to produce unbiased estimates of effect and their use is therefore discouraged. And the reason I can conclude that is that in all these studies that I used, the empirical Bayes method had been applied. So it was therefore possible for me to compare the results I got by employing the empirical Bayes method to the results I got by applying other simpler methods. And unfortunately, those results were not the same. And so the simpler methods did not produce unbiased results. And the shortcuts that I attempted were not successful in this case. Okay, let's move on to next one. Yeah. What should we do if we have a set of studies with low internal validity? This is a problem that we encounter quite frequently in reviewing road safety evaluation studies. Because if we look historically at studies, studies of black spot treatment, for example, or studies of road lighting and so on, you will very often find that these studies did not really control very well for confounding factors. And in such case, there are two main options, in my opinion. That is to reject all studies and wait for better studies to be made, or try to assess whether the studies have high theoretical or external validity. Because if they do, the fact that they have a low internal validity is perhaps not a reason for rejecting them after all. Because if they score well with respect to theoretical or external validity, we may still conclude that we should believe in those studies despite their poor control for confounding factors. And let me use studies of road lighting as an illustration of this. Yeah. In doing so, I and a colleague of mine, Alena, we developed what we call low-level theory. And by low-level theory, we mean theory specifying systematic effects, systematic variation in the effects of a road safety measure. And we proposed a set of hypotheses about this. And the idea was, of course, if these hypotheses are supported, then that indicates that the variation we see in the effects of the road safety measure are attributable to the road safety measure and not some confounding factors we did not control for. And with respect to road lighting, we proposed 10 hypotheses, which are on the next one. Yep. Yeah, you will probably not be able to read that, but there are 3 main columns. First, we have a set of what I call generative assumptions. And these are basic assumptions related to or based on sciences of perception, how people can see in daylight and darkness, how the presence of road lighting influences darkness, and so on and so forth. And from those, we proposed 10 hypotheses. Road lighting reduces the expected number of crashes in hour of darkness. It will have a larger effect in darkness than in twilight. It will have a larger effect when the share of crashes in darkness is high than when it is low. It will reduce the severity of crashes in darkness. It will have a larger effect for pedestrians and cyclists than for motor vehicles. Intense road lighting will have a larger effect than dim road lighting. Reducing the intensity of road lighting from a previous level will be associated with an increase in crashes in darkness. Road lighting of high uniformity will have a larger effect than road lighting of low uniformity. And road lighting will have a smaller effect on motorways than in other traffic environments, and it will have a smaller effect in built-up areas than in non-built-up areas. Well, those were the hypotheses. And when we reviewed studies, which we can see in the next one, then we found that out of these 10 hypotheses, 7 were clearly supported, 2 of them were not supported, and the last one was partly supported. So if we say partly is 1/2, then we had a score of 7.5 out of 10 possible. And that is quite good, I think. And it tells me that what studies have found with respect to the effects of road lighting largely reflects the effects of that measure and not various other factors that have influenced the number of crashes. So it shows that these studies have high theoretical validity. And we can evaluate external validity as well, which we can see in the next. I am running out of time, I can see, but I'm soon finished, so we will have some time for questions and discussions at the end as well. Yeah, this deals with the 4th and final type of validity, and external validity, which is the possibility of generalizing the results of a study or set of studies to other contexts than those in which the study was made. And as I indicated, a question that is often asked and which has to do with external validity is the question, do the results of this study apply in my country? And sometimes this can be answered by reference to theory, but or sometimes it is possible to provide a partial answer empirically as well, by looking at how consistent results of studies are between countries and over time. And in a paper I wrote some years ago, I developed a concept called range of replication, which is illustrated in the next slide, I think, which shows how studies, well, if you take count the number of countries that have reported studies and you count the number of years in which studies have been reported, then you can think of, as both of these variables increase, you have what I call an increasing range of replications, and you have more cases of studies that have been reported in different countries and different years. And if across such variation you find consistency, that means that you have an indication that external validity is high. I found so for road lighting, which we can see in the next slide. Yeah, I located studies made over a period of more than 60 years in 13 different countries. And then you can see how the best estimate of the effect of road lighting changed as a new country was added. To the left, you have the USA. That was where the first study was made. The second one in Britain. And then we move on to the right. Number 12 is Norway and number 13 is the Netherlands. And you can see that this solid line fluctuates a little bit up and down, but only a little. It is quite flat. So it is not the case that in some countries the effect of road lighting is completely different from what it is in other countries. It is, broadly speaking, the same everywhere. So this brings us to the final questions that I would like to address then. How can we make research more excellent? Well, there are two approaches to that, of course, two strategies. There is an internal one, and that is that we as researchers should continue to develop better methods. And that has actually taken place during my 45 years as a researcher. I think I've seen a large development toward better methods. It is not just the, the empirical based method, but accident prediction models as well, and methods of meta-analysis have been developed. And these allow us to give better presentations and synthesis of knowledge than we could before. But the external is to try to convince society, of course, that better research is needed. And to argue for the experiment on periodic motor vehicle inspection in Norway, my institute argued that previous studies were weak and inconclusive. And in that case, that argument was successful. But as far as I can remember right now, it is the only experiment that has been made of a road safety measure in Norway. Experiments have been made in many other countries, of course. Yeah, and then the final one about publication. Let's have a look at that one as well. Next one. Yep. Yeah. Hopefully, a good scientific journal will usually recognize a good study if it receives one, and publication will then usually be easy. That is my experience anyway. If I have done a reasonably good empirical study, I usually get it published. And publication should depend only on the methodological quality of a study and not on its findings, of course. And studies of evaluating the effects of road safety measures are valuable both because they have a practical application and because this knowledge, as I have said a couple of times, needs to be continuously updated. So we need to renew knowledge because the system changes and knowledge for that reason can get outdated. Thank you for listening, and sorry that we wasted a few minutes getting started, but at least we were able to get it done. Thank you.
Thank you very much, Rune. Okay, I see lots of uploads coming. So to remind you, we have 5, maybe we'll extend 3, 4 more minutes just to compensate for the lost time. But my suggestion is that those who want to ask a questions, just write your name. Don't write the question, just write your name in the chat and I will try to call you out. Henk, I see you wrote a long one. Do you want to say it instead?
Yeah, well, I can, but I'm not sure it's interesting for everyone. I was just wondering, Rune, thank you, by the way, for your excellent presentation. It's always lovely to hear how things should be done in science. But you showed a graph showing the effect of policies being above or below 1. And I was just wondering what happens if you multiply the outcome. So you multiply the effect with the probability with the effect. Would perhaps the average be above 1? So what you showed was just the probabilities of all the effects, but if you multiply, then you get the average effect. And that
Yeah.
would, because of this long tail on the right side of the graph, it would be completely different.
Yes. It did have a long tail to the right. That is quite true. Well, this was a multivariate study, and the coefficient for the policy variables was negative, of course, and indicating that it was associated with a reduction of fatalities, but it was not statistically significant.
I see.
So, but if you use the estimated confidence intervals, that was what I used. I divided it, in fractals, so the normal distribution to generate this, and that was the way I generated the curve. So my interpretation of it is that it is more probable that the policy variables were associated with a reduction of fatalities than the opposite.
I see. Well, let's leave it at that. Thank you.
Okay.
Okay, I have a small one regarding external validity. Now, actually, the biggest practical problem we have, if we see globally, is how to push the knowledge from Western world, where we have been doing traffic safety research for 40 years, how to translate it to the low and middle income countries where 90% of fatalities are happening. So do you have any good recommendations? How should we deal with the handbook of road safety measures, for example? Will it work in Ghana or Tanzania?
No, it will not. But that is not necessarily because the knowledge cannot be transferred. I think that some of it can be transferred fairly straightforwardly, and that is all those measures that are related closely to the laws of physics or biomechanics. Those results are capable of being transferred, I think. I mean, crash helmets and seat belts and road lighting and things like that, guardrails. I think those measures are effective or likely to be effective all over the world. Crash helmets maybe not, because if they are not worn correctly, they have no effect or a very limited effect. But other measures are more difficult. Police enforcement, for example. I mean, many years ago, I visited St. Petersburg because the Handbook of Road Safety Measures was translated twice to Russian. And the Russian edition of that book appeared in 1997 and 2000. And we gave courses to the Russians explaining the book. And they were not very satisfied with what it had to say about enforcement, for example, because this book does not tell us how to prevent corruption in the police. That is our problem, because the police is corrupt. Enforcement does not work in Russia. And that, I'm afraid, is what I think it is like in Ghana and Tanzania as well. Doesn't work because the whole society is corrupt. So that is what's got to change in those countries for those measures to work.
Okay, thank you. Okay, I see some comments popping up in the chat, but those are not questions. We have time for one more. Well, okay, no questions. The time is up. We're perfectly on schedule. It's 1 minute past 4 o'clock. I'd like to thank you very much, Rune, for being here today with us and sharing your experience. I definitely feel that I need to rewatch it once again.
Okay,
It
thank
was
you.
much to learn, much to digest here. Yes, and for all the participants, all the audience, I remind you that it's not a one single event, it's a series of webinars, and we already planning the next webinar in October, so please stay tuned. More exciting talks are coming. Thank you very much for being with us today. Thank you very
Thank you.
much, Rune, once again, and
Okay,
see you
thank you.
soon again.
See you.
Bye.